This is your systems and inequality reteach. So we're going to reteach both tests just in one video, since they really are both from chapter 4. So you're going to write down what you did wrong, explain what you did wrong, rework the problems with me, and then you're going to attend tutoring to do the extra practice so that we can help you. And that can be with the Avid tutors in the mornings, or it can be with me, and my tutoring hours are noted on each calendar. And then we can reschedule your retest for whenever works for you. Okay, so for the first one, both of these equations are already solved for y, so all we have to do is graph them. So the first one, get a pen here, the first one has a y-intercept of 3, so b is 3, and the slope is 2. I'm going to write that as 2 over 1, so I can see I'm going to go up 2 to the right 1. So let's see how this works, if I can graph this. Okay, so I'm going to plot 0, 3, and then I'm going to graph up 2 over 1. Up 2 over 1. And I'm going to keep dotting mine in, since drawing a straight line and hitting all the points, if you're in my class, you know that is difficult for me on the best of days, and with this, I'm not sure I can do it. Okay, so that would be our line. Let's see if I can kind of... There we go. Okay, this one has a y-intercept of -2, and my slope is 1 over 3. So I'm going to go up 1 to the right 3. So let me plot 0, -2, and I go up 1 over 1, 2, 3, and down. Oops, I did that wrong. Hang on. Up 1, 1, 2, 3 this way, and then down 1, 1, 2, 3 that way, and there's my solution. Okay. Of course, we need arrows because these are lines, not line segments. Okay, so a lot of people did that, but you didn't tell me what the solution is. You have to write that down. You can't expect the person who's reading the test to know that that's the solution. So that ordered pair is -3, -3. Okay, number 2, I have one equation solved for y. That makes me happy. I can just graph that. But this one, I have to go ahead and solve for y. So let me graph this first one. Y-intercept is 1, and my slope is 1 over 1. So I'm going to go up 1 to the right 1. Okay, so let me plot 0, 1, and then up 1 to the right 1, and you can see it's going to be right along here. Almost the parent function. Actually, it's a parent function translated up 1 unit. Kind of review that concept. There we go. Okay, so now I need to go solve this second equation for y. So I'm going to move the 2 over here by subtracting it, so now it's negative. So I have -2y equals -2x minus 2. Okay, make sure you see that this goes together. A lot of people miss that negative. They don't bring that negative sign down. So dividing everything by -2, we're going to get y equals x minus 1. Oops, -2, I'm sorry, x plus 1. So that's the same exact line. So if you graph it, you're going to see how it lays right on top of this line. That means every single point that I'm dotting in is a solution. So we say this line is a coincidental line because they're coincides. So we say the solution is all real numbers. So you need to write that down, all real numbers. Or if you wrote infinitely many solutions, that's fine too. Okay. Okay, solving by substitution. So basically, we're going to make sure one of these equations is solved in terms of one of the variables, so we can just substitute that into the other equation. And this first one, I already have solved for y. So I'm going to take this expression here and put it in for y there. So I'm going to have 2x plus 2 times. Now I have y, but instead of y, I'm doing 2x minus 1. And then the rest of my equation equals 22. Okay, now I'm just going to distribute and solve for x. So that gives me 2x plus 4x minus 2 equals 22. Combine like terms. Add 2 to isolate x. You end up with, let me go over here, 6x equals 24. Divide by 6, so x equals 4. Okay, so I have one of my variables. So now I'm going to take this, and you can substitute this into either equation. I'm going to choose to substitute it into this one only because it's shorter. And it's already y equals, so I won't have to do any manipulation after that, after I substitute it in. Okay, so y equals 2 times x, which is 4, minus 1. So y equals 8 minus 1, which is 7. So a solution for this one is 4, the ordered pair 4, 7. Number 4, you don't have anything solved in terms of a variable, and since we did say you had to do substitution, you need to solve one of these equations for one of the variables. I'm going to choose this one because y doesn't have a coefficient here. So if I solve this for y, and it doesn't matter, you could solve for y, you could solve for x. I'm just using y since it's going to be simpler. Subtract 2x from each side, and you end up with that equation. So again, I'm going to take this equation for y and put it in there for that y. And this is a case where you want to make sure you use parentheses to enclose that expression so you don't miss negative signs and whatnot. So negative 4x minus 2 times y, which is now negative 2x minus 12, equals 30. Okay, now you just go through and do distribution and get x by itself on one side. So negative 4x plus 4x plus 24 equals 30. Combine like terms, well, these cancel out, that's 0. So I end up with 24 equals 30, which is definitely not true. So this one has no solution. Remember, when you get a false statement, false means no, so no solution. Let me write that over here so you can see. No solution, and you're done. Okay, the next section is solve using elimination, which happens to be my favorite. So in this case, we need to eliminate one of the variables, and we can do that by multiplying one or both equations by a factor to make that happen. And as long as we multiply everything by the same number, it's equivalent, which makes it totally legal. So in this first one, I can get rid of the x's if I multiply this first equation here by negative 5. So I'm kind of thinking to myself, oh, if only that was a negative 5x, it'd be good. So I'm going to make it that way. The other thing you could do if you wanted to get rid of the y's is multiply the top by negative 5y to give you negative 10, and the bottom by 2, not negative 5y, I'm sorry, negative 5, you'll get negative 10y. And then those would cancel out as well. Okay, so that's what I'm going to do. I'm going to multiply that by negative 5 because I'm looking at my x's. So this now equals negative 5x minus 10y equals, let's see, negative 5 times 23 is negative 115. So when you do that, you see that these cancel and so do these. So you're left with 0 equals negative 60, which is not true. So this one also has no solution. Okay, everything cancels out, or both variables cancel out, so you end up with 0 equals some number, and so that's going to be no solution. If the constant terms also canceled, like if that 55 was 115 instead of 55, then you would get all real numbers, because then you would get 0 equals 0. Okay, so the difference again between no solution and all real numbers. All real numbers, you get a true statement. No solution, you get a false statement. Okay, number 6. I'm going to need to multiply each equation by a number so that I can get things to cancel out. since my y terms, I already have a positive and a negative, I'm going to work on those. So it's kind of like you're thinking I have denominators of 4 and 3 and I need common denominators. You're trying to find the least common multiple of 4 and 3 so that your numbers are as small as possible to work with. So that number would be 12. So that means I'm multiplying the first equation by 3, because 3 times 4 is 12. And I'm going to multiply the second equation by 4, since 4 times 3 is 12. I don't have to make one negative and one positive because my y terms are already one positive, one negative, so that's already going to cancel. Okay, so the first equation will become 15x plus 12y equals negative 249. And the second equation will be 12x minus 12y equals negative 48. Okay, so I'm going to combine them together. Okay, so 15 and 12 is 27. These cancel. And these are both negative, so I need to add them together. So that gets me 297. Negative 297. Okay, so let me move this up a little bit. And it just so happens that 27 is a factor of 297. Okay, so x equals negative 11, and that's our x term. So now I'm going to go back in, just like we did before, and substitute this in for x in whichever equation you want to. I'm just going to do that one since that's the one we can see right now. Okay, so let me get my pen and move this up a little bit. 3x, oops, 3x minus 3y equals, I've forgotten already, let me look, negative 12. So 3 times negative 11, that's what my x was, minus 3y equals negative 12. So negative 33 minus 3y equals negative 12. Add 33 to both sides. And you get negative 3y equals positive 21. Divide by negative 3. And y is negative 7. So the answer to this one is, let me use red so it stands out. The ordered pair is negative 11, negative 7. Okay, on the back, you have to write a system and then solve it. So on these, you can solve any way you want to solve. So let's talk about writing them. You have to define your variables. So I'm going to say let n equal nickels and q equal quarters. You can use x and y if you want. If you plan on graphing these, you might want to do that right now. So I have 47 coins, and they have to be worth $6.35. So my nickels plus my quarters have to equal 47 coins. I'll write that over here too so I can work it out. And they have to equal $6.35. Well, a nickel is 0.5 n, and a quarter, no it's not, 0.05. And a quarter is 0.25 n, and that has to equal $6.35. Okay, so let me write that over here, but before I do that, I'm going to scale it up so I can get rid of my decimal points. So if I multiply everything in there by 100, I no longer have decimal points. So that's the equation I'm going to write over here to work with. So 5n plus 25q equals 635. Okay, so I could solve the first equation for n and substitute it in. I could graph it, make nx and qy. If I do that, you're going to have to solve for y to get it into your calculator. So I'm going to use elimination because, like I said, that is my favorite. And I'm looking at this saying if only that n was a negative 5n, life would be easier. So I'm going to go make it a negative 5n by multiplying by negative 5. Okay, so I'm going to run out of room here. Okay, I'm going to go underneath. So negative 5n minus 5q equals 5 times 47 is 235, and it's negative, so negative 235. Okay, so I'm going to combine those, add them together. That's canceling. 25q minus 5q is going to give me 20q, and 635 minus 235 is 400. So divide by 20. So 40 divided by 2 is 20. So I have 20 quarters. So if I have 20 quarters, 20 or 47 minus 20 is 27. So I have 20 quarters and 27 nickels. So I'm just thinking I'm gonna, all right, 20 quarters, 27 nickels. Okay, you just write it like that. Okay, contestant on a quiz show gets 150 points for every correct answer and loses points for each incorrect answer. So I'm going to say x equals our correct answers and y equals incorrect. Okay, so I know we are answering 20 questions. So correct answers plus incorrect answers gives us 20. And now I have to go like what they're worth, go right down what they're worth. So 150 points for each or every correct answer. So that's 150x. Loses, so that's minus 250y. And in the end, this person had 200 points. So that's your second equation there. Minus 250y, I'm going to run out of room again, equals 200. Okay, and then I have x plus y equals 20. Okay, and I think this one, when I did my answer key, I think I did use substitution. So let me do that so you can see what that would look like. You can use elimination. I suppose I would multiply that second equation by negative 150 and get them to cancel out. Or you could graph it. You just have to solve them both for y. I'm going to do substitution, so I'm just going to solve this one. Let's do solve for x. So x equals negative y plus 20 because I subtracted y from both sides. Okay, let me work this out on another page because I'm running out of room. So let me add a page here. Page here. 13 correct. 13 correct. 7 incorrect. Okay, this one, a lot of people had trouble with this one, but this is really just like a question you answered last year or the year before, only we didn't have you write equations. We had you write expressions, and you had to realize they were equal to one another, and that's how we got you to do problems with variables on both sides of the equal sign. Okay, so we have Jay has written 24 songs to date, and then he writes an average of 6 songs per year. So there's our variables per year and how many songs. Okay, so our first equation is going to be Jay's equation. So Jay writes 6 songs per year. I forgot to define my variables. Let x equal the years and y equal the total songs. So Jay's is y equals, well, he already has 24 songs, and then he does 6 songs per year. So 6x plus the 24 he already has written. Jenna, I'm just going to call her Jen, has no songs written yet, but she's going to write, she thinks, about 12 songs this year. So her equation is y equals 12x. So those are our 2 equations. So they're both already solved for y. You can put those in your calculator and graph them and find the point of intersection and solve it. I'm going to do it the way you did it last year. You guys said, like, when will they both have the same amount? Or when will both companies cost the same? Those kind of questions. The same means equal. So we just set them equal to each other. Technically, what you're doing algebraically is substituting this 12x in for that y there. That's how it works for called substitution. So I'm going to subtract 6x from each side, so my x stays positive. So that's going to give me 24 equals 6x. Divide by 6, and I get 4. So x equals 4. Okay, and then a lot of people went and then found the y, but this only wants to know how many years from now. So how many years? 4 years. Okay, and they will have 48 songs after the 4 years. Right, and the last one, without solving, tell whether the system has no solution, one solution, or infinitely many solutions, and then explain how you know this. So we're not going to solve the system, but I am going to go ahead and solve this for y, because if they are both solved for y, I can see if they're the same line, which means they'd have infinitely many solutions, if it's a totally different line, which means it'll have one solution, or if they're parallel lines, which means it will have no solution. So when I add the 3x to both sides to get rid of the 3x on that side, I get y equals 3x minus 13. So they have the same slope and they have different y-intercepts, so they're not the same line. So that means these are parallel. And we know that parallel lines have no solution. So no solution is the correct answer. And you had to explain reasoning. If you didn't explain your reasoning, you didn't get points. So your reasoning had to include something about there being parallel lines. Some people told me the y's and the x's will cancel out. You'll not have a true statement, and therefore you have no solution. That's fine too. Okay, so some sort of explanation without you going through and solving the system. Just solving the one for y, or realizing that x's and y's are going to cancel out if you multiply the top by a negative sign to get rid of those 3 x's. And I have, okay, so here we are on a new page. So I have x equals negative y plus 20, so I'm going to put this in here, and come this way, for x in the other equation. Okay, so 150, but instead of x, I have negative y plus 20 minus 250y equals 200, the rest of my equation there. All right, so 150 times negative y is negative 150y. 150 times 20 is 3,000. 3,000. Minus 250y equals 200. So combine like terms, I get negative 400y plus 3,000 equals 200. Okay, then I subtract 3,000 from both sides, which gives me negative 400y equals negative 2,800. Divide by negative 400, and you get y equals 28 divided by 4 is 7. So 7 questions incorrectly. So if I have 7 questions incorrectly, and the total number of questions was 20, then that makes x equal to 13 questions correctly. So let me go back. Okay, so now the inequality part, which was its own test to kind of shorten things up a little bit. So the same thing is true about these as it was about the systems. You still have to graph the line, and you still need it solved for y to do that on a coordinate grid. So I'm going to go ahead and solve this first one for y. So I'm going to add x to both sides. So I'm going to end up with y is less than or equal to x plus 3. Okay, so first thing I'm going to do is graph y equals x plus 3. Oops, plus 3. And then I'm going to have to decide solid line or dotted line. Because I have an equal sign underneath here, this is going to be a solid line. All right, so I go 2, 3. Okay, 0, 3, 1, 2, 3. And then my slope is 1. So again, I still have to do this. B is 3, slope is 1 over 1. So I'm just going to dot in my slope, the parent function, translated up 3 units, and draw my line. It is really important that your line does go all the way off your grid here, because now we have to decide where we're shading. Okay, so this is less than or equal to. So that's telling me I'm thinking I'm going below this line, but I want to make sure. So I'm going to pick a point. I like to pick, as you know, 0, 0. If 0, 0 is definitely on one side of the line, then pick that one, and that'll help you know where to shade. If that above below is a little confusing, because sometimes it looks like left and right. So we need, I'm going to go back to the original equation here. 0 minus 0 less than or equal to 3, because my test point, like I said, is going to be 0, 0. Okay, so is 0 less than or equal to 3? Yes, it is. So we're going to shade where that point is, which is this area in here. And that's, you get the idea there. Okay. All right, number 2. The inequality is in standard form, so first thing we have to do is solve for y. So I'm going to do that by doing subtracting 6x from both sides. So that's going to give me 2y is greater than negative 6x minus 2. And I need to divide everything by that coefficient. The coefficient's positive, so it's not going to change the sign or anything. So it's still going to be greater than negative 3x minus 1. So I'm going to graph this line where this y-intercept is negative 1 and my slope is negative 3 over 1. Again, I'm doing negative 3 over 1 to remind me I'm going to go 3 down, 1 to the right, or 3 up, 1 to the left. All right, so before I start graphing this, I want to know if I'm going to do a solid line or a dotted line. That is just an inequality sign. There's no equals underneath it. So that's going to be a dashed line or a dotted line. Okay, so I'm going to plot 0, negative 1 for my y-intercept. And then I'm going to go down 3, 1, 2, 3 to the right 1, up 3, 1, 2, 3 to the left 1, and I'm going to do a couple more so I can 1, 2, 3, 1, draw a reasonably straight line. There we go. Oops, but I colored it in. It has to be dashed. So when you do that, you just come back in here with your eraser and you erase some sections. So it's a dashed line, okay, and it should go through those points. Now I have to decide where to shade. Well, this is greater than, so I'm thinking above, and that's that side to me. But let me check. Again, 0, 0 is not on the line, so I'm going to test that point. Let me get some space here. So I'm going to test 0, 0. Okay, so I'm going back to my original equation to test it. Okay, so 6 times 0 plus 2 times 0 has to be greater than negative 2 if that's where I'm shading. So 0 is greater than negative 2, so that's true. So I'm shading where that point is, and that's this side of the line. All the way down the grid. There we go. All right, number 3. Which graph best represents this inequality? 4x minus 8y is less than or equal to negative 16. So the first thing I do is check to see, this is going to be a solid line. Oh my goodness. Okay, so this is going to be solid. So, but when I look at all my answer choices, they're all solid. So that's not going to help me. So I do need to solve this for y so I can see which line is graphed and then where to shade it. So 4x minus 8y less than or equal to negative 16. So I'm subtracting 4x from both sides, minus 4x minus 16. And then divide everything by negative 8. And I'm getting y. Now I divided by a negative, so that's going to flip that sign the other way. So y is greater than or equal to negative 4 divided by negative 8 is positive 1/2. So 1/2 x And negative 16 divided by negative 8 is positive 2 plus 2. Okay, so that's the inequality I'm looking for. So I'm looking for the line that's graphed y equals 1/2 x plus 2. So I'm looking at these, and it just so happens that all the y-intercepts are at 2. So that's not going to help me. So I have to figure out where this is shaded. What will help me, though, is my slope is positive. So C is a negative slope, so it can't be C. And D is B rather is a negative slope, so it can't be that one. So now I just have to decide, do I shade above or below? Okay, so you might say, well, above, it's greater than. Okay, but let's test a point. So let's see. Let's test 0, 0. That's easily on one side of the line. So this is 0, 0 here, 0, 0 here. So let's see if 0, 0 is true or false. So 4 times 0 minus 8 times 0, is that less than or equal to negative 16? Well, that gives me 0. Is 0 less than or equal to negative 16? No. 0 is greater than. So 0, 0 should not be shaded, which means our answer can't be D, it has to be A. Okay, and then the back we have systems of inequalities. So they work the same way as systems of linear equations, whereas you graph both of them and see where they intersect. But remember, inequalities have many, many solutions. So we're going to graph both and see not just where the point intersects, but where the shaded areas intersect, because the system will also have many, many, many solutions. So the first one's already solved for y, so let's go ahead and graph that one. So I have b equals 3, 0, 3, and then for my y-intercept, my slope is negative 1 over 1. Okay, and this is just greater than, so that tells me I need a dashed line. So let me make my graph a little bigger so I can see it here. So 0, 3, y-intercept, and then down 1 to the right 1, down 1 to the right 1, up 1 to the left 1. I may dot a couple of these in, so it's going to be important to get a nice line here. And I have to remember not to draw a line, right? It's dotted or dashed. So here we go. That might be. Just connect a couple of these points and make it a line. Okay, dashed line. Now, should I shade above or below? Well, it's greater than, so I would say above. But let's pick a test point. 0, 0 is clearly on one side of that line, so I'm going to test for this first one, 0, 0. So is 0 greater than negative 0 plus 3? Is 0 greater than 3? Nope. So 0, 0 can't be shaded. So I'm going to shade on the other side of where 0, 0 is, which is up here. Oops, might help if I had a pen. So this is all getting shaded for that inequality. Okay, now the next inequality, we're going to need to solve for y. So use blue for that one. So I'm going to add 2x to both sides, which is going to give me y is less than or equal to 2x minus 1. So I'm going to plot my y-intercept at negative 1. My slope is 2. I'm going to write it 2 over 1, so I know I go up 2 to the right 1, and this is equal to, so this one is going to be a solid line. So negative 1 goes here, and then I go up 2 to the right 1, oops, up 2 to the right 1, or down 2 to the left 1, down 2 to the left 1, and my line goes like so. Okay, now above or below? Well, it's less than, so I would think below here. But let's test 0, 0. Again, that's not part of the line. That's clearly on one side of the line. So let's test it and see. So we're going to test 0, 0 in this one as well. So negative 2 times 0 plus 0 less than or equal to negative 1. Well, negative 2 times 0 is 0 and plus 0. So is 0 less than or equal to negative 1? No. So we're not going to shade where 0, 0 is. We're going to shade the other side of the line. So let's go over here, and we shade the other side of the line, not where 0, 0 is. So yes, that is this side. So we shade that in, and it's going to overlap this here. Hang on here. So our solution is where they're overlapping. So our solution is right in here, where blue and red make purple. So that's your solution set right in there. Okay, so use the graph to answer questions 7 and 8. I have no idea what happened. There must have been more questions here, so it's really 5 and 6. Okay, so number 5 here. You can see that the solution is this the darkest gray area. So I was thinking 0, 0, I could just put 0, 0 and see which one is true, but you'll get 2 that end up being true. So you got to pay attention to, is it a solid line or a dotted line? Is it originally shaded above or below? And then is that where the overlap is going to be? So I'm going to use 0, 0 to eliminate some answer choices, but then I'm going to have to do some more work. And honestly, when I made my answer key, I solved each equation for y and checked out the graph to see if it was true. But we can use the fact that that is in the solution set. So first thing we're going to do is test 0, 0. So is 0 greater than 3? Because that'll be, 2 times 0 plus 0. 0 is not greater than 3. So it can't be A. Negative 0 plus 0 greater than negative 2. Is 0 greater than negative 2? Yes, it is. So 2 times 0 plus 0 is less than or equal to 3. Yeah, might be that one. That works. This one again, 0 is greater than or equal to negative 2. That's true. And is 0 less than 3? That's true too. So it could be that one. This one says 0 is greater than negative 3 because that ends up being 0, or negative 2. That's true. 0 is less than 3, so that's true too. So that only eliminated one answer choice. So let's go through and solve these for each of them for y, and then look at our graph and see if that works or not. Okay, so in C, if I solve this for y, I'm going to get y is greater than x minus 2. So I'm going to go look and see that line and see if it's dotted or solid, because I know from this, oops, I shouldn't do that, that it's going to have to be dashed. So let's go see which graph, which line is that equation. So y-intercept of negative 2, that would be right here. Right here. And then a slope of 1. So up 1 over 1. That's this line. This line right here is y equals x minus 2. That's a solid line, not a dashed line, so C is out. If I go to B and solve that one for y, I get y is greater than or equal to negative x minus 2. So again, I go to negative 2, and that would be down 1 over 1. That would be this line, which is not a line on the graph, so B is out. So that makes D our answer, but let's make sure we know why D is our answer, just in case, it's not that easy on your test or retest or EOC or whatever. All right, so when I solve this for the first equation for y, I get y is greater than or equal to x minus 2. Okay, and that's true because that's the line, and that's the line, and it's solid. Okay, so greater than, it's shaded above. So I see that it's shaded above this way. Okay, if I test 0, 0, that worked because that's how we were trying to eliminate the answer at first, so that's all good. This one, I get y is less than negative 2x plus 3. So let's go back to the graph and see. 3 is here, and it's supposed to be, oops, hang on, there's your y-intercept of 3, and my slope is negative 2. So down 2 over 1, and these points do lie on this line, and it is dashed because it's not equal to. So this line is, the equation of the line is this, so that works. And it says it's supposed to be less than, which means it's going to be shaded below, which would be here. And then we have our double shaded or cross-hatched area. So our correct answer is D. You really have to work through each one of these to eliminate choices and make sure you're doing it right, especially because they're all so very similar. Okay, and the last one, which of the following points is a solution to the system? Basically, I'm going to graph all those points and see which one ends up in the double shaded area. You could substitute each one into these equations and see which one gives you true statements. I think it's easier to use the graph. So 0, negative 3. Let's see, 0, negative 3 is here. 0, negative 3 is right here, not in the double shaded region, so not that one. Let me check out negative 2, or negative 1, negative 2. Negative 1, negative 2, well, that's right there. So that's in the region. So that should be our answer, but let's just check these other ones out just to see. 1, 1 ends up on the line. That is not part of the solution because this is a dashed line. So that can't be part of the solution. So that might be a little tricky there. So it's not that one. And 2, 3 ends up being, let's see, 2, 3. 1, 2, 1, 2, 3, there's 2, 3. Not in the double shaded region. So that one is not correct. So negative 1, negative 2 is the point that's in the doubly shaded region. That makes it a solution to the system. Okay, now this bonus one I'm not going to do right here, but I'll work it out. You can look at the work. Basically, you're going to solve, you have 3 systems to solve. So you have to solve in terms of one variable, substitute. So it's just kind of like an extra step. But I'll work it out and have it available for you to look at if you come to tutoring, but I'm not going to do it right here.